Hello and welcome to geometry class. Today's lesson is on proving lines parallel. You might wonder, what exactly does it take to prove two lines are parallel? If they look like they're parallel, does that mean that they have to be parallel? Not necessarily. The human eye can be somewhat deceiving, so we're going to figure out exactly what you have to know to determine that two lines are for sure parallel. Now, you learned in algebra that if you find the slope of two lines and the slopes are equal, that proves that they are parallel. In geometry, we have some additional ways to determine that lines are parallel to each other. It says, if two lines in a plane are cut by a transversal and certain conditions are met, then the lines must be parallel. So there's 5 different statements where it's if this, then the lines are parallel. You do not have to know that all 5 of these are true. If you know any single one of these are true, then the lines have to be parallel. So it's just a matter of knowing one of those will be all you need, okay? Now, the first one says, if corresponding angles are congruent. We learned about corresponding angles earlier in this unit. Remember, that's like if you have an angle in the upper right of one parallel line and then the upper right of the other. Those positions are matching and those angles are congruent. Those lines have to be parallel to each other. The next one says that the alternate exterior angles are congruent. Then the lines have to be parallel. And the next one after that says consecutive interior angles are supplementary. Remember, that means they add to make 180 degrees. Or if you know that the alternate interior angles are congruent. Or lastly, if you know two lines are perpendicular to the same line. So those are 5 different ways that you can determine that the lines are parallel. Now, down here at the bottom, it says, find X so that line L is parallel to line M. So we're trying to figure out what X would have to be to make the lines parallel. And it says, identify the postulate or the theorem that you used. So when we say that, we're meaning like which type of angles had to be either congruent or supplementary to make those angles, to make those lines parallel. So we'll start with number 1. We have 5x minus 5 in this upper left angle, and we have 6x minus 20 on this lower right angle. Notice that these are on alternate sides of the transversal line. And notice that they are both on the exterior of the parallel lines. Those are called your alternate exterior angles, and they are supposed to be congruent. So the postulate or theorem that we used is the alternate exterior angles one. And now we need to set these up so that they are equal to each other and solve for x. So 5x minus 5 has to equal 6x minus 20 in order to make these two lines parallel to each other. So we're going to get our x's together first. I like to move them to whichever side has the bigger x, which is our 6x here. So I'm going to subtract 5x on both sides. All I'm going to have on the left now is a negative 5. 6x take away 5x equals 1x, or just x, minus 20. And now I need to get my constant numbers on the same side away from the x. So I'm going to add 20 to undo the minus 20. So negative 5 plus 20, or 20 minus 5, is 15. X is equal to 15. That's what x has to be to make these alternate exterior angles congruent and thereby making the lines parallel. Okay, let's look at number 2. It has 4x plus 20 here and 6x here. Notice these two angles are on opposite sides or alternate sides of the transversal line, and they are both in between on the interior of the parallel lines. So these are called alternate interior interior angles, and we need them to be congruent in order to say that the lines are parallel. So I'm going to say 4x plus 20 equals 6x. And now I'm going to get my x's together. So I'm going to subtract 4x from both sides of the equation. 20 equals 2x. And now I'm going to divide by 2 on both sides of the equation to get the x by itself. And so 20 divided by 2 is 10. X is equal to 10. Okay, that's what x has to be in order to make these alternate interior angles congruent, thereby making the two lines that you see here parallel. All right, number 3. There's a couple of different ways you could approach number 3. We have a 3x plus 15 here and the little right angle 90-degree mark box here. So you could think of these like you did number 2. Alternate interior angles need to be congruent. Or you could also use the bottom one here where it says if two lines are perpendicular to the same line, then the lines are parallel. So I'm going to use that one just so we can have some variety here. Two lines perpendicular. I'm going to use that upside down capital T symbol for perpendicular to the same line. It would have been correct also to say alternate interior angles just like number 2, okay? So these need to be equal. Both of these need to be 90 degrees because they're both going to be perpendicular to the transversal line. So we're going to go 3x plus 15 must equal 90. And then we are going to solve that algebra equation for x. So we subtract 15 to start, getting our constant numbers together on the right. 3x is equal to 75. And then we have to get x by itself, so we divide by 3 on both sides. X equals 25. That takes care of number 3. Okay? I am going to skip number 4 and go on to number 5. Number 5 has a 2x here and a 3x minus 20. This would be a good one for you to try on your own. So why don't you pause your video, give it a shot, and then start it again to see if you got it right. Okay, hopefully you had a chance to try this one on your own. These are called alternate exterior angles, like number 1 was alternate exterior angles. So they are supposed to be congruent in order to make line L parallel to line M. So we're going to say 2x must equal 3x minus 20. Now, normally I like to get the x's together on the side where the bigger x is to start. But if you do that on this particular problem, it adds an extra step because you have nothing left on the left side if you subtract 2x from both sides. And then you have to add 20 to both sides. That's fine. You can do it that way, but since it's going to leave nothing, I'm going to go ahead and subtract the 3x from both sides. If I take 2x minus the bigger number 3x, that's going to leave me negative 1x equals negative 20. And so then just divide by the negative 1, and x is equal to 20. Okay, hopefully you got that one correct. And if you did it the other way, where you said 2x equals 3x minus 20 and subtracted the 2x to leave you 0 here, minus 2x is 1x minus 20, and then add 20 to both sides, 20 equals x. That's another correct way to do that problem. So either one is fine. Okay, number 6. We have the 5x plus 20 on the bottom right of this line L and 70 on the bottom right of this line M. Those are called corresponding angles because they're in matching places with respect to our parallel lines. So I'm going to call this the corresponding angles theorem or postulate that we're using here. So we know that our corresponding angles should be congruent to make the lines parallel. So we'll say 5x plus 20 should equal 70. And now we'll get our constant numbers together by subtracting 20 on both sides. So 5x is equal to 70 minus 20, which is 50. And then to get the x by itself, we divide both sides by 5. So x is equal to 10. And that's the answer to number 6. Okay, so on the back, we have one fully worked out proof, proving that lines are parallel. I'm going to leave that one for you to look at if you'd like an extra example. And I'm going to do this one at the bottom where it says complete the proof. So it says, given that angle 1 is congruent to angle 5. Notice I'm marking on my picture the given information. That way visually I can see what's going on. Angle 15 is congruent to angle 5. Oh, it's congruent to the same one I already have a symbol on. Okay, we have to prove line L is parallel to line M and line R is parallel to line S. So that's a lot to focus on here. I think we're mainly going to focus on this first one, that line L is parallel to line M. Okay, so the first statement says angle 15 is congruent to angle 5. How do we know that? Well, it says it right here. It's a given statement. So my reason for knowing that is that it was given in the problem. The next one says angle 13 is congruent to angle 15, okay? So look at the picture. Angle 13 and angle 15. Why would we know that those two angles need to be congruent? Do you remember what those are called? They are opposite from each other at an X on the picture, the intersecting lines. So those are called vertical angles. Remember the word vertical angles? We learned that as one of our vocabulary words earlier this year. So vertical angles are congruent. We learned that theorem earlier this year. Notice I'm using abbreviations. You're welcome to do that too. Angles, and this is the congruent symbol, okay? Now then, I'm going to go ahead and mark that on the picture. The 13 has to be the same as the 15. Now it says angle 5 is congruent to angle 13. Well, notice we've got angle 5 is congruent to angle 15. We already said that. And we said 15 was congruent to 13. So that would indicate that 5 needs to be congruent to 13 by substitution. Basically, if you say these 15s are the same, you could take out the 15 and replace it with the 13. That means 13 and 5 would have to be the same. So the reason would be substitution. That's when we take out one thing and replace it with something else that it's equal to. Sometimes we call it the substitution property, but I'm fine if you just want to write substitution, okay? So line R is parallel to line S. Why would we know that? Well, if angle 5 is congruent to angle 13, it would be because we've proven already that these corresponding angles, upper left, corresponding in matching places, corresponding angles are congruent. That makes the lines parallel. Okay, now the next reason, number 5, is the other given statement. So we already used 15 is congruent to 5 on the first reason and statement, but we haven't used this one yet. Angle 1 is congruent to angle 5. That was another given piece of information, okay? So the last statement should be the remaining statement that we needed to prove. Line L is parallel to line M. Line L is parallel to line M, and that's because if the corresponding angles are congruent, then the lines are parallel. So because angle 1 and angle 5 are congruent, that means these two lines, L and M, must be parallel to each other. Okay? Well, I wish you all the best and hope you have a wonderful day. Good luck on your homework. Please let me know if you need any help at all. Bye for now.